projectiles in 2 dimensions. Example 4. A ball is projected horizontally from the top of a building which is 200 meters high, and the ball will fall 88 meters from the foot of the building. So projected at A horizontally, and it falls and hits the ground at B. At A there is no vertical velocity component, there is only a horizontal velocity component initially. So to work out the time of flight, the initial displacement here is 0. The ball is falling downwards, we'll take the downwards direction as positive. So looking at vertical motion, the displacement here will be positive because anything below this line has a positive displacement. So vertical motion, positive direction, sy equals 200 meters at B. The initial vertical component for velocity is 0. The ball was projected horizontally, so that's why it's 0. We're not interested in the vertical velocity component at B, so I've crossed that one out. I've taken that direction as positive. Gravity acts downwards, so this is positive. We're after the value of t. So suvat, and the formula without v is this one. Substitute the values in, and we have the time of flight, 6.389 seconds. So to work out the initial velocity here, the value of u, so now we're looking at horizontal motion. So using the formula s equals vt, where s is the horizontal displacement, 88 meters, v is the horizontal velocity. Horizontal velocity doesn't change anywhere in the motion of the ball, so in this case it's just this value here, which is u, and we've already worked out t, the time of flight, the time taken for the ball to cover a horizontal distance of 88 meters. So substituting the values in and solving gives us u is equal to 13.77 meters per second. And once again, there was no vertical velocity component, so what we have is u is equal to ux. Part C, to work out velocity, magnitude and direction when t equals 3 seconds. So initially the ball is here, it has a horizontal velocity component of 13.77 meters per second, and that value doesn't change horizontally. As the ball moves, it picks up a vertical velocity component because it's moving downwards as well as horizontal, and that velocity component vertically gets larger, and at some point where t equals 3 seconds, we're trying to work out the magnitude of this velocity. So we need the horizontal and vertical components to work out this. So to calculate this vertical velocity component, we look at vertical motion, suvat, downwards direction is positive because vertically the ball is falling downwards, so we're not interested in the vertical displacement. The initial velocity vertically was 0 meters per second. This is what we're after. This is the value that's here. The acceleration due to gravity is positive. Gravity acts downwards, same as this direction, and obviously t equals 3 seconds. Suvat formulae, the one without displacement s, so v equals u plus at, substitute the values in, and we get 29.4 meters per second for this velocity component, and it's pointing downwards. So now we have both of these velocity components worked out. We can represent them on a right angle triangle, horizontal, vertical. Using Pythagoras' theorem, that means v is equal to 32.4 meters per second. This velocity here, this is what we've just calculated, the magnitude of this. To work out the direction, so where the arrow is pointing, we need to do some more trigonometry. So tan theta is the opposite over the adjacent, so we get theta as 64.9 degrees, and it's below the horizontal. We need to state this as well. For practice, try these questions, and you'll notice that exercise 6b is missing because 6b uses vector notation, so your component ij format, and I've left that till later.